All right, so we're starting our new unit. It's on, like I said in the notes yesterday, it's on all the integration techniques you already know, which is actually not very vast because it's primarily U sub and some trig rules and the power rule, but there's never been a huge, oops, I'm sorry, there's never been a huge difficulty trying to decide what to do because we have a very limited number of things we know how to do. This chapter, once we're done with these first couple days of just making sure we have the stuff we know how to do done, we're going to start learning new techniques of integration. So it becomes pretty complicated, I'm not going to lie, because it isn't the techniques themselves. Like Lucy's going to understand each technique. And on that day, when we're doing integration by partial fraction decomposition, that's really fun to say, she's going to be good at it. Everybody is all the time. It's when they all get mixed together, like on this mega integration packet from AB, that it gets trickier because you have to decide, do I do this by parts? Do I do this with partial fraction decomp? Do I do this with trig sub? Do I just do U sub? Do I do a power rule? Maybe it's just a heart and all I had to do was break it apart. You know what I mean? So it's all the ones from AB and then four more. They're actually not more complicated. I think you're going to find them not more complicated than U sub, it's just there's more of them to keep track of. So the task is going to be knowing how to start it. So I'm starting you off on this mega integration packet. Yesterday, I told them that it's not due till the Sunday, like coming up this Sunday before next week starts. And the reason I'm doing that is because some of you are going to have to focus on some test retaking. And it tells you in here whether you're eligible and what that entails. So I'm not going to go through that because it's not, about half the people don't even need to deal with it. So I'm not going to talk for 10 minutes or whatever about it. But you should definitely interact with this. I'll give you your test back today. Lucy's going to remind me, right, Lucy? And if you're a distance learner, I will get yours back through email in the next day or two. So, and the key is attached right here. It's deadly with the key for this packet. Really make sure you're trying to figure out which technique to use before you look at the key. All right. Any questions right now from you guys? If you didn't take the notes yesterday, you're going to take them after this first 5 minutes here. If you took the notes yesterday, you're ready to start. But I talked about how on that first page, so go ahead and look at the first page of the packet. I'm going to grab Lucy's. On the first page, there are things that look similarly that are each done differently. In each row, there's one you can't do. You can't find the antiderivative with techniques that you know so far, if ever. All right? Get up here, honey. So let's go. Yesterday with them, I talked through row A. Okay, so talking through row A, you should immediately know how to integrate that first one. What rule? Power, done. The next one to the right, you look at it and you run through your arsenal of stuff. I would not multiply that out and use the power rule. That would be a nightmare. What would I use on the next one over here? U sub, and it'll work. The next one, you're going to get stuck because you're going to go, well, the only thing I can try is U sub, and that's a failure, because the derivative of the radicand isn't living outside of it as a multiple, right? So that's a complete failure. So that's the one you can't do. In each row, there's one only that you can't do, okay? The last one is not U sub. It won't even work, but you can use some algebra to FOIL it out and then go. So each one has one you can't do and one with U sub. And it says up in here, all right? I also told them yesterday to beware of the loners, the ones you don't see very much. So just so if you go in here, Lucy, I'll highlight yours for you. I said, take a look at number, and if you're at home, you can fast forward this because we talked through it yesterday, but look at number 22. That's an obscure technique. We used it last year and it didn't pop up much, but it's still there, okay? And if you watched the notes yesterday, what did I say to try when the derivative of the numerator is greater than or equal to that of the denominator? That's a long division. So I'm going to write LD by yours loose. Okay? The other one that I said to watch out for is one like 29. Actually, on the key, I didn't do 29 because in years past, I said, you won't need to know that one. But guess what popped up on a practice exam this year? The test got changed, but the practice test for the exam you were supposed to take had one of these on it. So the 2019 practice exam that they sent me had one of these. So I focused on it more this year because I'm like, oh, maybe that is fair game now. So what do you think we use with 29? It is a complete the square one. And who do you think it'll pass off to, arctan or arcsine? It's going to pass off to arcsine. So I'm going to write a CTS so you know to complete the square with that one. All right. The only one, and now this is where if you're at home, we didn't discuss one like 17. It's most of these you're going to, like I saw you guys who had started talking about them. You're like, I got most of them. I couldn't figure out. That's how it should be. You should be like, yep, yep, yep. This one's throwing me for a loop. And that's why we're doing this. If none of them throw you for a loop, I just wasted up your entire 2 days. So I want you to find the ones that are going to throw you for a loop. I anticipate 17 might. So I want you guys to look at 17. Then we're going to go do 2 on the back page. I'm just going to give you work time. All right? So go look at 17. I'll hand that back to you, Luce. And it's not one of the things in the notes from yesterday where I said these occur the most often. And I actually didn't even put it in that, and these sometimes occur because I forgot about this kind. So if you heard me in the notes, I said, we'll just kind of add to the, we'll do it sometimes. Do you guys know what procedure that one is, that number 17? It's the weird kind from last year.
Is it when you look at what Q equals and then find what X is?
Yeah, if you can't hear, I'm going to say it closer to my thing. Somebody said that it's when you, let's go do it. The only thing we know right now is U sub, so that's your only hope, right? And all of those work after the first page. They all have an antiderivative. So who would you want to let U equal? The x plus 1, right? The inside function. I'm assuming that's what's inside. I'm not looking at it. Okay, so let me know if she said it wrong. So U would be the x plus 1. So you're now integrating root U, correct? But you have to write the rest of it in terms of U. Agreed? So if U is x plus 1, what's x? U minus 1. Excellent. And what's du? 1 dx. So you're actually challenged with integrating, and I can't see it anymore, but it was u minus 1 in parentheses, I'm trying to picture it in my head, root u du, is that right? Negative. Okay, thank you, over root u. Thank you. So that's actually going to become a heart. What are you going to do with it? Break it apart and go on to use your power rule. So that's a weird one. All right, so now what we're going to do, and you guys can just ask me weird ones and maybe I'll throw up a video, or if I'm getting the same question a bunch of times, the bottom left one on the front page is kind of a doozy. But I'm just going to let you find your own issues. We're going to go to the back page right now and do 2 together. Instead of taking notes, I thought, well, since this is a review of AB, I'm going to steal yours again there, Starkey. Or I could just grab my own. What the heck? Let's go look at 44. We'll kill that one off together. So if you're at home, you should be tackling 44. So it says to find the value of y at 5 pi thirds. So this must be a function of an angle. It is. It's an angle as the independent variable. Dy d theta, the rate that y is changing as my angle changes, is equal to the cosine squared of the input over 5 times sine of theta over 5. And furthermore, they tell me y of 0 equals 0. That's a lot of information up there. We need to pick it apart. All right, the directions say to find y, which means I need to solve this for y. When I'm done, I don't want to know the rate that y is changing. I want y as a function of theta. Do you remember doing those, Lodemeyer? I want to figure out what y is. It's sort of separation of variables, but it's super easy to separate. Because what's the only thing I need to move over? D theta. So I know the rate that y is changing is cosine squared theta fifths. You guys were good at this last year, so I think you'll just need one little, like as a full class, we were really good at this topic. So we whip that d theta over. So it's sort of separation of variables, but for all of these, they're giving you the derivatives. You just need to whip the bottom differential over. How do we undo derivatives when we're solving? Because we want to figure out what y is. We integrate. All right, perfect. And this is really a 1, right? So the antiderivative of 1 with respect to y is just y. dy dy is 1, right? So there it is. So boom. Now I'm challenged with integrating this sucker over here. It's obvious who your winner is, right? Who's your integration technique is kind of what I meant. I should go back up here by my mic. Who's the integration technique that I'm going to try for? Yeah, it's going to be a u sub. There's 2 inside functions, theta fifths and cosine theta fifths. Who do you think u is? There we go, because its derivative is a multiple of the rest of the integral. So we're going to go up here and write u equals cosine theta over 5. Then I'm sitting there with, I'm going to start, I like to write it as I go. I'm now sitting there with u squared. I've taken care of that. All right. Next, if you don't take care of something, you did something wrong. So that's why it's kind of nice to create it as you go. Who is my du? What's the derivative of cosine? It's negative sine theta over 5 times what? It's like if it was x over 5 and it was du dx. This is du d theta 1/5. Yeah, exactly. The derivative of the guts, it's kind of like what's the derivative with respect to theta of 1/5 theta? And you go, well, 1/50 theta d theta. Right? It's the same thing. You're nodding. Awesome. So this would be, and then times a 1/5, right? And then that's du d theta, and we whip the d theta over. So I'm doing one of them really slow. But the rest of this integrand is only this part of it. It's the sine theta fifths d theta. So I fraction correct it with a what? Negative 5. Yeah, negative 5 du is going to replace all of that. So we put constants out front. So I'm going to go du. I don't want to put negative 5 in there. Some books teach that, but like I always tell you, I like to keep the constants out front. Now I'm ready to integrate it with my power rule. So I go negative 5 u cubed over 3 plus c. I should have asked at the beginning to see if you guys remember. Why do they give me that? To get Carl. Yeah, without it, I get what's called a general solution, and I'm going to write down what that is. Right now, we've got negative 5. What was my u choice again? Cosine cubed theta fifths, or all of it in parentheses. Just make sure you, if you put the 3 on the outside, make sure you use parentheses. Where am I? All over 3, right? Plus c. So here's what I call my general solution. There's an infinite number of functions that vary by a constant whose derivative is this. That's what it means, okay? But they're locking me into a specific one. We talked about that last year with graphs. When you leave Carl in there, you're just leaving in the exact same function, just moving up or down the y-axis. But their derivatives at a specific spot are always the same. So if I want to get locked in somewhere, like 0, 1, then they'll tell me y of 0 is 1. And they'll lock me in on this specific case. All right, you're nodding again. Awesome, I love it when we nod. So when I put in a 0 for y, I have to make sure that I get cosine cubed of 0 fifths plus c. What's cosine 0? 1. So negative 5 thirds times 1 cubed plus c. So who's Carl? You're now 5 thirds. Carl, you've been so many things in our time together. He's now 5 thirds. He's a man of many constants. All right, here we go. Here is my specific solution to the differential equation. I'm using the proper notation so that when College Board says find the specific solution to the differential equation, and you know how to do it, I want Toby to know that she's supposed to do it. Does that make sense? Because knowing a process, it's kind of funny. In Algebra 2, they're so good at like the quadratic formula. Like they can all sing it. X equals negative b plus or minus the square root of b squared minus 4c all over 2a, right? But then if you say, what are the intercepts of this parabola? They don't know that that's what they use. See what I mean? So memorizing a process doesn't do you much good if you don't know what the process is used for. So make sure that you're not only good at separation of variables and solving, but you understand what you're doing. We're finding a specific solution for y. It was negative 5/3 cosine cubed theta over 5, right? And then plus 5/3. What is its derivative? What is it? The original function, right? Or that what it says at the original prompt, I would say. If we took its derivative, it would be that. All right, so now what does it say to do? We're not done. It says to actually do something. It said to find y of, what did it say, 5/3 or 3/5? 5/5? So then you just plug it in and watch your unit circle. I'm not going to finish that off. You can plug and chug, okay? The next one I want to do with you, I'm going to do 2 on this back page. We're going to go hit 49. I'm going to have you do it on your own. And I'm going to have you change that y prime to dy dx. It makes these a little bit more user-friendly. So you guys at home, I'd pause the video and go try it. These guys here, I like this because it's got the natural log to review as well. So I like this. I'm going to pause though and let you guys do it, and then we'll, sorry guys at home, we're working on 49, the very last one in the packet. All right, did it go? Yeah. Oh, there it is. Yeah, and I'm have you noticed I've been trying to keep notes under 20 minutes? I'm really trying. It's pretty easy in BC, sometimes with AB not so much. So those of you at home, I started it so they could kind of look up and get a trigger if they needed to. And I've also highlighted, my U choice was an inside function. It was ln 5x, and lucky for me, its derivative lived in the rest of the integrand. It was 1 over x. So my 1 over x dx can get replaced with du. So when I rewrite this, oh wow, this is fun. Oh, it's satisfying. It would be sine of what? U, right? Then what's the rest of it? Du. Yeah, du is all of the 1 over x dx. This is so cool. Oh. Yes, it feels so good. I'm giving notes in a giant fat highlighter the rest of the year. Just kidding. So what's the antiderivative of sine? Negative cosine. So this is negative cosine of u plus my good friend Carl. Oh, this is so fun. I gotta change colors. Which is negative, cosine, and it self-corrects the dash. Did you see that? Like if I do it a little off, oh no it didn't. I thought it did. Negative cosine of my U choice. What's my U choice?
Natural log.
I almost can't find, this is so pretty. Natural log 5x, then what? Plus Carl. How many had it right?
Why'd you do that?
Wait, didn't you forget a
You forgot the 1/5.
Yeah.
There's no 1/5.
So what about natural log of 5?
Because it was U prime over U.
Oh.
Yeah, that was a great See, A group, don't you miss these B people? They're actually pretty fun. Sometimes they get on my nerves, but not usually. Anyway, the question, it was a good one. So those of you at home said, well, what about, because somebody said, what about the fraction correction from the 1/5? It killed itself off in the U prime over U, because the derivative of 5x is 5, right? Over 5x, and it kills itself off. Actually, the ln ax's derivative is always 1 over x. Yeah. So, but I wouldn't try to memorize that. I would just always do it. All right, so we are done. Boy, that's pretty. I like it. Let's see if I can make it.
Those poor students.
Who? The people at home?
Yeah.
Why?
It's just written over everything.
Alright.
Be a smiley face.
Yeah,
That's the weirdest looking smiley face.
it's because it's Halloweeny. That's not his name. Unfortunately. All right, guys. Go ahead and work on the front. through it. If I get the same question a lot,
Our test back.
yeah. If I get the same question a lot, I'll do it and record it.